Welcome to the video for C2.2.4 ionic bonding. So this is going to be split in two parts. So this is the first part, and we're going to look at how to draw dot and grass diagrams for ionic compounds and how to write the formula for ionic compounds. So the first thing is how to write a formula. So how to write ionic formulae. So in order to write the formula of an ionic compound, we need to know the charges on the ions first. And we need to know that the charges add up to 0. So the sum of the charges on the ions is 0. So that means you've got to have the same number of positive charge as negative charge. So if I take my simple example of sodium chloride, so sodium is in group 1, so it's going to have a charge of +1, and chlorine is in group 7, so it's going to have a charge of -1, so it's going to be Na plus and Cl minus. So in fact, let's just write the rules here. So group 1 is going to be +1, group 2 is going to be +2, group 3 is going to be +3, group 4 doesn't tend to do ionic compounds, it does covalent, so we'll ignore it. If we had group 5, that would be -3 charge, group 6 would be -2, and group 7 would be -1, and then group 8 don't form ions because they've already got a full out shell. So going back to my sodium chloride, so it's Na plus Cl minus, so it's +1 and -1. So in that case, I've got the same number of charges already, so the formula just becomes NaCl. So let's take a more complicated example. So if I take potassium oxide, so potassium's in group 1, so again that's going to be +1. Oxygen's in group 6, so it's going to be 2-. So now I can see that I've got 2- and +1. So to balance the 2-, I need 2 pluses. So I'm going to need 2 of these K pluses. So that's going to give me K2O. So remember, when we have these little numbers, they need to be subscripts, they need to be lower and smaller than the chemical symbols. And that 2 belongs to the element before it. So that means I've got 2 potassiums, but only 1 oxygen. And then one last example. So aluminium is in group 3. So it's going to be Al3 plus. Oxygen is, as we've already said, in group 6, so it's 2-. So this one's a bit more complicated. So I've got Al3 plus O2-, so I need another one of that. That gives it 4 plus. So I can't divide 4 by 3, so I'm going to add another one. So that's 2-. So now I've got 6- and 3 plus. So if I have another one of these, that's now 6 plus and 6-. So that gives me Al2O3. Now, instead of doing it that way, we can do what's called the crossover method. So the crossover method means that I just swap the numbers round. So if I have, let's do the same one, there's Na plus Cl minus. So that's, remember that's 1 and that's 1. So I just write my formula out again, and that 1 goes to there and that 1 goes to there. So because it's a 1, I don't need to write it, so it just becomes NaCl. And the way I've drawn those arrows, you can't really see why it's called the crossover method, so I'll do it on the next one. So if we have K plus O2-, O2-, right, so if I write out my KO, that 2 goes to there and that 1 goes to there, so that makes K2O. And you can see that's the same as we've got there. So if we go to the last example, Al3 plus O2-, so the 2 goes to the aluminium and the 3 goes to the oxygen, so that gives Al, so the 2 goes there, O, and then the 3 goes there. So the 3's gone there, the 2's gone there. It's called the crossover method because you get this cross. And you can see it doesn't matter which method we've done, we've come up with the same formula. So you need to go and have a bit of practice of that. Right, so that's writing the ionic formula. Now we need to be able to draw the dot and cross diagrams for ionic compounds. And this is quite straightforward if you've done the lesson before and you've understood it. So if you can draw the electronic structure diagrams for the individual ions, then we're just putting two different ions together here. So if you've understood the previous lesson, it should be straightforward. So let's go back to our sodium chloride. So we know that that's Na plus and Cl minus. So if I look in the periodic table for sodium, that's 23 and 11. And chlorine is 35.5 and 17. So if I draw my individual atoms out first, so the sodium has got 11 electrons. Remember, we're looking at the smallest number to get the number of electrons. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And now I'm going to write Na in the middle just so I know which one that is. And then my chlorine has got 17. So remember, you get 2 electrons in the first shell, and then the others can hold 8. So I've done crosses for the sodium, so I'm going to do dots for the chlorine. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I need 7 more. 1, 2, 3, 4, 5, 6, 7. So if we do it like this, even ignoring the fact that we've written the charges up there, so we know it's going to be Na plus and Cl minus, you can see that the sodium can either lose 1 or gain 7, so it's going to lose 1. So it's that one that's going to lose. And you can see chlorine's got 7 in its outer shell, so it needs to gain an extra 1 here. So what happens when we form an ionic compound? So when sodium reacts with chlorine, this electron goes from the sodium to the outer shell of the chlorine. And then if I'm asked to draw the electronic structure of the final ionic compound, we'll get, so if I draw out sodium again, so that's 2 and 8, and I'm not drawing the final shell because I've lost that electron, but remember I need to put a square bracket around it, and it's lost 1 electron, so it's plus 1, so I put a plus in the top right hand corner. Remember, I don't need to put the 1, but if it was 2 plus, I'd have to write 2 plus. And then for the chlorine, so I'm going to draw the original chlorine out. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7. And then I need to draw so the electron that came from the sodium, I'm going to draw as a cross, and that's to show that it's come from the sodium. And then again, I need to draw a square bracket around it. And because it's gained an extra electron, it's got a charge of -1. So top right hand corner outside the bracket, I need to write minus. So that's the simplest example. We'll do a slightly more complicated one now. So if I do, instead of sodium chloride, I do sodium oxide. So if I was to draw sodium out, that's the same as it was in the one example before. So that's 1, 2, and then 1, 2, 3, 4, 5, 6, 7, 8. And then, sorry, that should be drawn on the circle. Make sure you're not quite a slapdash as me. And then oxygen is, so oxygen is 16, 8. So it's got 8 electrons. So it's going to be 1, 2. It's got 6 left. So 1, 2, 3, 4, 5, 6. Now the reason this is slightly more complicated is that I can see I've got 1 electron there from the sodium to give up. But if I look here, I've got 2 spaces for electrons in the oxygen. So this oxygen, to get a full outer shell, needs 2 electrons. So this electron is going to go to there. But in order to fill the shell, I need to get another sodium atom to lose another electron. So I'm going to draw another one out here. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Sorry, I'm not doing very well at drawing these actually on the circles. And then that one's going to go there. So I need 2 sodium atoms here to give 2 electrons that the oxygen needs. And this is reflected in my formula here. So you can predict how many of each you're going to do by working out the formula first. So if we had Na plus and O2 minus, then that 2 comes to there if I'm using the crossover method. So it becomes Na2O. So I find it easier to write the formula out before I draw the dot and cross diagrams, but you don't have to. You can see how many you need by looking at how many electrons are going from each. So to draw my final structures, then I'm going to have 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, and it's lost that electron. So I'm going to draw a square bracket around that, and it's lost an electron, so it's plus. Now I'm going to be lazy here, but you should draw both of them out. But I'm going to have 2 of those, so I should really draw the same thing out for that, but I've got a time limit on my video, so I'm going to leave it as that. And then my oxygen is going to become 1, 2, 1, 2, 3, 4, 5, 6, and then it's gained 2 electrons, 1 from each sodium. And again, we draw them as crosses to show that they've come from the sodium. And again, I need my square bracket because now it's charged. Now, because it's gained 2 electrons, I need the charge of 2 minus there. Right, so what you need to do now is practice this. So there's some practice examples in the lesson plan for you to have a go at. The other thing that we need to consider is what an ionic bond is, but we'll go into this in the next lesson in more detail. But when I've got this positive ion here and this negative ion here, so the ionic bond, when we talk about an ionic bond, it's the attraction between the positive ion and the negative ion. So you've always got a metal which becomes a positive ion and it's positively charged. You get a non-metal which is negatively charged, and then the ionic bond is the attraction between the two. Okay, thank you for listening. See you next time.